Good afternoon, boys and girls, and all the teachers that are watching. My name is Ngaka, and today we are going to work together to have a look at what we have in chemistry, the organic chemistry. And then our focus, we'll be looking at the nomenclature, how do we name and draw the organic compounds. And then later, we've got 4 sessions. Later, we'll do the physical properties and see what is it that the properties, what we have learned in grade 11 about the intermolecular forces, the impact that it has on the boiling point, the melting point, and the vapor pressure. So today we are going to start off by looking at the whole of organic chemistry and see how the names are, how we name these compounds according to the number of carbons that we have. And then towards the end of the lesson today, I'll show you the homework that I'm going to give you that we are going to do the correction of when we meet again next week. All right, so we can start. I'm going to mostly use the PowerPoint presentation that you are looking at, and the first thing that is appearing there is organic chemistry. This is the chemistry of carbon compounds. We'll be looking at the whole carbons and what is the structures that are made up of, and some uses of the structures later. All right, so why is it so important to talk about organic chemistry? If you look at the processes that are happening on Earth, most of them are based on organic chemistry. You can think of the car that you are using to travel to school. It uses petrol, and petrol is one of the compounds that we have in organic chemistry. And then it's also useful for the products that we have, like the plastics that we are using to carry our grocery from the shops, the drugs that we are using when we are not well. We are not talking about the drugs that people are buying, the Mentrax and that. We are talking about the medicine. The drugs we are referring here to is the medicine. So all those are made from the chemical, the organic chemistry. And then the petrochemical, this is the petrol, the diesel that we are using to drive our cars, the explosives that we are using to extract minerals from the ground, the paint, these are the ones that we are using to make our houses look beautiful, and so on. So there are so many products that we are using that are made from organic chemistry. And then here are some terminologies that I want you to have a look at. And then if you struggle a bit about these terminologies, we can have a look at the exam guide that your teacher should have given to you on page 15 of the exam guide. Let me just switch over to this so that I can take you through this. On page 15, this is where you've got your organic molecule, and these are all the molecules that we'll be looking at: alkanes, alkene, alkynes, and then later we'll be looking at the haloalkane, the alcohol, the carboxylic acid, the esters, the aldehydes, and the ketones. And when we look at this, we will not be focusing on the cyclic. So the cyclic are not part of your syllabus. And then the terminologies that you must know, the molecular formula, the structural formula, the condensed formula, the hydrocarbon, the saturated, unsaturated compounds. So these are the things that you must know. So if you want the correct definition for all of these terminologies that we are talking about, have a look at the exam guide. Don't look at the definition from the textbook, because sometimes it is explained in the way that the examiner is not requiring. So you must have a look at the exam guide at how the terminologies are explained. All right. So let us continue. So the homologous series, we say here these are the compounds with the same functional group and the same general formula. And then the functional group, the bonds, the atoms or group of atoms that determines the chemical and the physical properties of an organic compound. And then the general formula can be used to determine the molecular formula of a compound in a homologous series. And then the homologous series, we are talking about the alkane, alkene, alkyne, and haloalkane. And then on the side there, we've got the functional group. How do you identify that this compound belongs to the alkane, this one belongs to the alkene, this one belongs to the alkyne? So if you look at this one here, where you've got a, let me just take out my pointer so that I can show you what I'm talking about. Change the ink. Okay, right, is fine. If you've got a single bond between two carbons, then you know that this compound belongs to the alkane. If there are double bonds between two compounds, two carbons, you know that this one is the alkene. And then the triple bonds between two carbons, that one is the alkyne. And then the haloalkane will be the carbon with the X, where this X stands for any of the halogens. Here we are talking about fluorine, chlorine, bromine, iodine. So those are your halogens that when we combine with the alkanes, we refer to them as haloalkane. And then the other ones that we have are the alcohols, the aldehydes, the ketones, carboxylic acid, and the esters. So this is what I want you to do before we go any further. It is important to know the name of these compounds and how we name them. So this is what I want you to do. Take out your book and the pen, and I want you to draw for me this table here. It should look like the one that I'm drawing here. All right, and then let's say here you've got number of carbons, and then the second column there, let's call it prefix. We are doing a little bit of English here. And then this one will break it like that and call it suffix, where we will break it into those. So this is what I want you to draw in your book, because I'm going to teach you the names here depending on the number of carbons, so that later when we get into the details of naming these compounds, this table will become very useful to you when you look at the homologous series or the functional group in which where you are looking at whether this is a single bond between carbons or double bond or triple bond, and then you just look at the number of carbons and the name will just come up automatically. So this one we'll call it alk, and then let me change the pen here and call it alkane. And then the next one, alkene. And the last one, alkyne. All right. So these are the three homologous series that we refer to them as hydrocarbons, where you've got only the hydrogen and the carbon in a compound and nothing else of another atom. All right. And then when you are done drawing this table, let me just give you a few seconds to draw the table so that I don't leave you behind. Okay, I believe you are where I am now. We'll call this 1, 2, 3, 4, 5, 6, 7, and the last one, 8. So what you have to know is, with the name of these organic compounds, is the one that contains 1 carbon up to 8 carbons in your long chain. So the prefix for 1 carbon, we'll call it meth, and then this one is eth. 3 carbons is prop. 4 carbon is but. 5 carbons is pent, like pentagon. 6 carbon is hex, like hexagon. 7 carbon is hept, and then the 8 carbon is oct, like October. All right, and then if you've got a saturated compound, remember we said a saturated compound is the one that saturated. You only have 1 bond between carbons. So if there's a single bond between carbons, you know that this is saturated. And when you look at our homologous series here, the one that is saturated is the alkane. The alkane is our saturated hydrocarbon, because we only get a single bond between 2 carbons. All right. So let us go back to our names there. So if it has 1 carbon, if the compound has only 1 carbon, we call this one meth, and it will end with ane. So that will be methane for the compound that has 1 carbon. The example for methane, that is, we've got 1 carbon, and then you know that this carbon is in group number 4, so it can form 4 covalent bonds. And then because we are talking about hydrocarbon, it's the compound that only contains the hydrogen and carbon. So this will be methane. 1 carbon and 4 hydrogens. So that will be our methane. So when you go to alkene, remember we said alkene, we need to have a double bond between 2 carbons. But then when you look here, we only have 1 carbon. We cannot have double bond when we only have 1 carbon, because the double bond has to be between 2 carbons. So this one, we don't have any of the names there. We don't have any of the names there under alkyne, because it needs triple bond between 2 carbons. And then when you go further to the compound containing 2 carbons, they will start with eth, and then it will end with ane or in or ine. So this one, we call it ethane, ethene, ethyne. All right. So what I want you to do is, I want you to complete the table using the same method that I'm using now. So what this will help you is, it will help you when you have a compound, and then you check how many carbons you have in the long chain, and then the number of carbons in the will determine the parent name. We'll talk about this later. We'll determine the parent name, and then it will be easy for you to know the name, because you would have practiced how to write these names using this table. So this table will become very important for you to master and know it. All right. So let us go back to our presentation. We have talked about those and the esters. And then later I will show you how the alcohol looks like, the aldehydes and the ketones, the carboxylic acid and the esters. The esters, when we talk about them, you will see that there's the combination of the alcohol and the carboxylic acid to form an ester. So when you get to the section of ester, I'll explain further. The type of molecules that we get here, we've got molecular formula, structural formula, and condensed formula. This is very important because during the examination, if you are asked to draw the structural formula and then you give the condensed formula, you'll get that answer wrong because you would not have answered what was being required in the question paper. So if it's a molecular formula, you know that this is the atom, the type of atom, and the correct number of each molecule. Like in this case, the molecular formula of this is C3H8. And then when you draw the structural formula of the same molecular formula, this is how you write 3 carbons, and you know around each carbon there should be 4 bonds. So this carbon has 3 hydrogens, and the other bond is bonded to a carbon, and the second carbon has 2. Okay, I just want to change the color. The second carbon here has 2 bonds. In actual fact, it has 4 bonds because other 2 bonds are bonded to carbon, to this carbon and that other carbon. So CH2, and then the last one is CH3. So this we refer to it as the structural formula. It has a structure. So with the structure, we need to see those bonds, and we need to see what this bond is bonded to, the atom that the bond is bonded to. And then the condensed structure, this one we don't need to see any lines that represents the bond. So if you are asked about the condensed structure, this is how you should do it. This will show you the condensed structure. Alright? So we'll see when we get to the questions, when they say to you, draw the structural formula, you need to know how to draw the structural formula, and the molecular formula, you need also to know how to write it out. Sometimes they ask you to do some calculation. You'll see when we do the examples how you go about doing the calculations to find the molecular formula. Now, the other term or the terminology that we have is the isomer, the structural isomer. This, we have the same molecular formula. When you talk about the molecular formula, we talk about the number of carbons and the number of hydrogens. So the number of carbons for this structure and the number of hydrogen will be the same for both structures. But then when you look at the shape of the 2 structures, they won't be the same. The example that you are seeing there is of butane. You remember from our table, bute has 4 carbons. So there's 1, 2, 3, 4 carbons, and each carbon will have 4 bonds. And then in this case, the the molecular formula for butane is C4H10. And then this will be the structural formula for butane. And then what we can do is, if we take this carbon and then we remove it from there, and then we put it there, we put it here. You see, we have changed the structure. But then when you count the number of carbons for structure number 1 and the number of carbons for structure number 2, there you've got the same number of carbons, you've got the same number of hydrogens. So we refer to this structure as isomers. All right? So the isomer, we say, is a molecules or a compound that has the same molecular formula but different structural formula. All right? That's an example. So later when we are asked to draw the isomer of the compound that will be given, I will show you how you go about doing it, and then it will be easy for you to sort it out. The IUPAC names. This is the system that is used internationally to name the organic compounds. So this IUPAC name has 3 parts. You've got the prefix that we have on our table there. The prefix, it is this part that we talked about, which will be either one of those. And then we also have the parent name, which is determined by the number of carbons, and then the suffix will be determined by the homologous series or the functional group. Here we are looking at the number of bonds that we have between carbons. Whether we've got single bonds between 2 carbons, that will be alkane, so it ends with A-N-E for the alkane. If we've got double bonds between 2 carbons, you will have an alkene, and then the name of the compound will end with E-N-E. Let's just do the examples for those so that you can follow what I'm talking about. Let us take the first compound with 2 carbons, carbon number 1 and carbon number 2, and we said each carbon has to have 4 bonds around it. And then you must also show the atoms that this bond are bonded to, the hydrogens. Okay, so this, because there are 2 carbons, you know that this will be eth. And then there are single bonds between this. We've got only single bond between two carbons. Then it ends with ANE. So this we call methane. And then let's have another one where we've got those and then double bond between two carbons. And then each bond has to have hydrogen, a hydrocarbon. So when you look at this first carbon, it has 1, 2, 3, 4 carbons. You must always try to check that you have 4 carbons around each carbon, because sometimes you will make a mistake of putting another bond there, and then there will be 5 bonds around one carbon, which is incorrect. So this one, because it has 2 carbons, we know that it will start with eth, and then because there are double bonds between 2 carbons, it will end with ENE. So this is ethene. And then the other one, the last one that I'm going to draw for you, is where you've got 3 bonds between 2 carbons. And then there's hydrogen there and hydrogen there. So this one, we've got 2 carbons. It will also start with eth. And then the triple bond between 2 carbons, the suffix will be INE. So that's ethyne. So I've got ethane, ethene, ethyne. So this, we say the homologous series in which this one belongs is the alkane. And then this, the second one, the compound belongs to alkene. And then this last one, it belongs to the alkyne. All right. So this, what I have drew here is your structural formula, and then those are the names, the IUPAC names for the different compounds that I drew. And then this is the homologous series in which they belong to. All right. So they say when you name the compound, you look at the prefix, the parent name, you check how many carbons you have, and then later you look at the homologous series in which this compound belongs. So the homologous series, like I said, you must check whether you've got either single bond or double bond or triple bond. And then this is part of what we have on the table, where you've got 1 carbon, and the parent name will be meth, 2 carbons eth, 3 carbons prop, 4 carbons but, 5 carbons pent, 6 hex, 7 hept, and then 8 oct. So we only go up to number 8. And the organic compounds, they go up to, I think they go up to around 60. But we only go up to carbon number 8. So let us now focus on the alkanes. Alkanes, if we look at the number of carbons and the hydrogens, it has the general formula of CnH2n plus 2. And then this N here, it represents the number of carbons. So if you've got 1 carbon there, we'll have 2 multiplied by 1 plus 2, which will give us 4. So 1 carbon and 4 hydrogens. You remember from the example that we drew that 1 carbon has 4 hydrogens around it. 1 carbon with 4 bonds of hydrogens. All right. So that is the structure for methane. All right. So this general formula helps you to predict the name of the compound by just looking at the number of carbons. That, okay, this number of carbons, I'll have so many number of hydrogens. And then let's say you've got 5 carbons. For 5 carbons, here you have 2 multiplied by 5 plus 2, which will give you 12. So 5 carbons and 12 hydrogens, and the name there will be pentane. That is the general formula. And then the functional group here, we say the alkane contain only the carbon and the hydrogen because we are referring to it as the hydrocarbon. So the hydrocarbon, we said that is the compound that contains only the carbon and the hydrogen atoms. So we also have between 2 carbons, you'll have single bonds between 2 carbons. And then these are saturated compounds. Remember, we said saturated compounds, those are the compounds where you do not have multiple bonds. By multiple bonds, what do we mean? We mean there are no double bonds or triple bonds. So those are your multiple bonds. We only have single bonds between carbons, and then you only have hydrogen and carbon in the compound. So that is the hydrocarbon. So when you look at the alkane, there are rules that we have to use to name the compounds. And we've got 3 steps that you have to follow when you name this compound. The first step is you must name the parent of the hydrocarbon. And how do you do that? You look at your chain, or you look at the whole compound. You must determine which one is your longest chain. If you've got 2 chains of the same length, you can choose from either side. It's still okay. The name will still be okay. And then some of these compounds have what we call substituents. And what do we mean by substituent? A substituent, let me just show you here by drawing. If we have a compound like this one, you remember when we're talking about the isotope, we had a structure like the one that I'm drawing there. The hydrogens, and then here we had another carbon with 3 hydrogens. So we're referring to this, the one that is connected to the one with the long chain. This part here, we call it substituent. Sometimes they refer to it as a branch or a substituent. So we say you must check on you must look at the compound and check which one will form a long chain. How many carbons are in the long chain, and the number of carbons will determine the parent name. And then from there you check your substituent. All right. Step number 2, after identifying your substituent, you must number the carbons that are in the parent name. So how do you number them? You must number them from left to right and also from right to left, because this will help you to check which numbering is correct. You'll see when you do the example what do I mean. And then if you've got 2 substituents of equal length from both sides, you don't need to worry about which side you choose, because if you've got, for an example, if we have 5 carbons in our long chain, 1, 2, 3, 4, 5, and then we put our substituent at carbon number 3 there. So it doesn't matter whether I start counting from this side, 1, 2, 3, 4, 5, or I start counting from my right hand side, 1, 2, 3, 4, 5. My substituent, it is still at carbon number 3. It doesn't matter which side I take. So that is what they mean there. Okay? And then the last point there under step number 2 is if you've got 2 different substituents, then you must number them according to the alphabetical order. So when you number them according to the alphabetical order, the one that comes first in the alphabetical order must have a lower number. You'll see when you get to the examples what do I mean by this. I'll also emphasize at that point. All right. Number 3, you identify the number of substituents. If I've got 1 carbon and the 3 hydrogen, then my substituent will be methyl. And then if there are 2 carbons and 5 hydrogens, then my substituent there would be ethyl. And then if there are 3 carbons with 3 carbons, they're supposed to have 3 multiplied by 2, which is 6 plus 2, which is 8. So that one will have 7 hydrogens, and then my substituent will be propyl. All right? And then you must assign the number to each substituent according to the point that on the parent name that this substituent is attached to. And then if you've got more than one type of substituent, we said you must name them according to the alphabetical order. And then if you've got two substituent or three substituent that is identical, maybe we've got two of the methyl substituent or two of the ethyl substituent, then you use the, before you write methyl, you must use di. So if there are two of the methyls, you will name that dimethyl or trimethyl if there are three. Or if it's the ethyl, it will be diethyl or triethyl. All right. And then when you look at the number of the parent name, the di and the tri do not affect the position of your naming, like carbon number 3 and carbon number 5. For example, if you've got a methyl and then somewhere you've got ethyl, the di will not affect, and then you say D comes before E. So here you must look at the name of the substituent, which will be the M, the methyl, not the di. You don't look at the di for the naming. And then lastly, you must separate the numbers with the comma and then the number and the word with the hyphen. You'll see when we write the name of these compounds. All right, let us look at the first example. The first example is straightforward. This one, you just check how many carbons we have on the long chain. If we count them, you've got carbon number 1, 2, 3, 4, 5. So there are no substituent, therefore you just name it the way it's appearing. And then because we've got 5 carbons, the name of this compound will be, okay, let's check step by step. We said first you check that you've got single bonds between all the carbons that are there. Therefore it belongs to the alkane, and then it will end with ANE. And then we said you've got 5 carbons, and then there are no substituent, and therefore the name will be pentane. All right. Then let us look at example number 2. Example number 2, you've got the structure that is appearing there. Let me just quickly draw it so that I can take you through it. Okay, I'm almost there. Let me just switch over so that you can see. Okay, this is the structure that we have with the hydrogens. You see, for each structure, I'm indicating the hydrogens. So if you don't do that during the examination, you are going to be penalized. You must show the hydrogens. Don't just draw. Even if in class the teacher doesn't show the hydrogen, don't draw it the way the teacher is doing it. Show the hydrogens, because at the end of the year, you are the one that is going to be marked and not the teacher. So be a clever learner and show the hydrogens. All right. So here is our structure or the compound. We want to give the name to this compound. So if you remember step number 1, we said you look at the long chain. So if we check here, we've got 1, 2, 3, 4, 5, 6. If you go that way, you've got 6. And then if I go this way, I'll have 1, 2, 3, 4, 5. So 5 is less than 6. I won't choose 5. And then if I go this way, 1, 2, 3, 4, 5, 6. So the long chain doesn't have to be straight. Sometimes it bends, like I'm showing you here. I can count 1, 2, 3, 4, 5, 6. I still have 6. So I'm going to choose this one because this one is easy for me to work with, unlike the one that bends. So we said after identifying the long chain, we number the carbons in the parent. And then we'll number them 1, 2, 3, 4, 5, 6. And then I said to you, after doing that, you must also number it the other way around. 1, 2, 3, 4, 5, and 6. All right? And then step number 2, we said you must identify your substituents. The substituents, if you look here, you've got a substituent with 1 carbon. So this will be a meth. Because there's 1 carbon, I know that's one, it will be a methyl. And then my substituent there has 2 carbons. This one will be ethyl. All right? And then step number 3, we check which one comes first, because you've got M and E. If you look at our green label or the bottom label, E is at carbon number 3 and M is at carbon number 4. And then when I look at my red, M is at carbon number 3 and E is at carbon number 4. Therefore, according to the rules of naming the hydrocarbons or the alkanes, the one that comes first alphabetically must have a lower number. That is what we meant with that bullet there. The one that comes first alphabetically must have a number. So E comes first in the alphabetical order. It comes before M. Therefore, E must have a lower number. So I'm going to choose the bottom numbering instead of the top numbering, because bottom numbering gives me 3, top numbering gives me 4, and I know that 3 is lower than 4. All right? So step number 3, they say, after you have identified your substituents, when you name this, you must also label or give the position, the carbon number, where this substituent is appearing. So we say here at carbon number 3, we've got ethyl. And remember, according to what we just read there on those bullets, let me just go back and show you the last point there. We said you use the hyphen and the comma to separate. Then the hyphen used to separate the number and the prefix, while the comma used to separate the numbers. All right? Now, because we only have one ethyl substituent at carbon number 3, the next thing that I must have there is the hyphen. And then I will write ethyl. And then I have another substituent there with the M. Because I'm going to write a prefix, I must also put the hyphen, and the position of this one is at carbon number 4, a hyphen, and the substituent name is methyl. And then the long chain has 6 carbons, and all of them are single bonds. 6 carbon, I know it's hex, because they are all single bond. It will end with A and E. This is very important. When you give this name, please make sure that you don't do a mistake there of writing it like methyl. I'll just write this last part, hexane, where you have the space between the E and the H there. Because what we have realized is when you are marked at the end of the year, you get penalized for this. So please write it not this way, it's wrong, but make sure that there's no space in between the name of the compound. It is just one name. All right? So the name of this one will be 3-ethyl -4-methyl hexane. So that is the name of our compound. So let's see whether we have done it the way that it's supposed to be done. We said it contains all single bond, therefore it belongs to the homologous series of the alkanes. And then the suffix there will be ANE. And then because it has 6 carbons on the parent name, we are going to use the prefix HEX, hex, for 6. And then we've got the substituent of ethyl and another substituent of methyl. All right? And then we number our carbons, number 1, 2, 3, 4, 5, 6. And we also do another numbering, 1, 2, 3, 4, 5, 6. And then we check, alphabetically we said E comes before M, and therefore E has to have a lower number. We'll count from left. We'll take the red numbers there. And then at carbon number 3, we've got ethyl. At carbon number 4, we've got methyl. And then the parent name is hexane. So that is how you name your compounds. If you are given the structure and they say give the IUPAC name, that is how you must name the compound that is given to you. Okay, before we get to the alkene, Let me just take you through the homework that you are going to have and show you what is it that you are supposed to do. So the homework that you are going to have, it is the one that you are seeing there. I've put for you the rules so that you don't forget them. And then the first activity, the first compound there, you've got a structure. The condensed formula that you must write the name of this compound. And then the second one, you've got the structure that you must also write the name. Number 3, you have the condensed formula, and then you have also to write the name of this one. This also is a condensed formula that you must also write the name of the compound. All right. So I'm not going to discuss these ones. You will have them for your homework, and then we are going to do the corrections next time when we meet. And then as you go down, there are other structures that you must also give the names. There are about 8 of them that you must give their names. And then the second activity here, you've got the name, and then you have to draw the structure. So I want us, before we go to the alkene, I want us to do one of these as an example so that I can help you and take you through the steps on how to draw the structure if you are given the name. So the one that you are seeing there is 5-ethyl 2-methyl heptane. So this is what you do. The name is 5-ethyl 2-methyl heptane. All right. So let's see how you should go about drawing this one. This is where you must start. You start with the parent name. The parent name is hept, and you must know how many carbons are there for hept. And then it ends with ANE. You should also know that this is only saturated structure. It has single bonds between all the carbons. So hept, we said it's 7 carbons. So we'll have carbon number 1, 2, 3, 4, 5, 6, 7. All right, and each will have those bonds. And then because you are drawing the structure from the name, it is your choice on how you number. So you must number it in any way. So I can number it from this one, carbon number 1, number 2, 3, 4, 5, 6, 7. And then after I do the numbering, I go to my name there. I've got the 2 substituents. One is at carbon number 5, the other one is at carbon number 2. I think here, the name there should be, my numbers here are not correct. Let us just change them and say this is at carbon number 2, and then this one is at carbon number 5. I will show you why I have changed the numbers. If you remember, we said alphabetically, the one that comes first must have a lower number. So if you have 5 and 2, then it doesn't make sense because E comes before M. Therefore, at carbon number 2, I will have the substituent with 2 carbons, and then at carbon number 5, I will have a substituent with 1 carbon. And then from there, I put all my hydrogens. Hydrogen, hydrogen, hydrogen. All right. So this is the structure for 2-ethyl 5-methyl pentane. All right. So that is the structure for our compound. So when you are given the name and you have to draw the structure, it's up to you which side you want to number. You can number from this side that way, or you can number from this carbon the way we have done it. It's all up to you. So this is how you draw the structure. This is the structural formula for that compound. All right. So the other examples there, you'll have them as homework. Let me just change this one. We said that is 2. This should be 5, so that it becomes proper. All right. So the remaining there will be part of your homework. Okay, let us go back to our presentation. So the next homologous series that we are going to look at is the alkene. We are done with the alkane. We are now focusing on the alkene. The alkene, like we said, we are going to get the double bond between 2 carbons. And we don't have the name of the alkene that only contains 1 carbon, because the double bond has to be between 2 carbons. The general formula is CnH2n, and the functional group, we've got C double bond C. So you'll have a carbon with a double bond and another carbon, double bonds between carbon. So this is unsaturated. And what do you mean by unsaturated? It means when we go and talk about chemical reactions, this compound will react easier than the alkane. The alkane, you said they are saturated, and then the alkene are unsaturated. It is easy for us to break the double bond into single bond, and therefore alkene will react easier than the alkanes. So we get double bonds between 2 carbons, where this compound only contains the hydrogen and the carbon. And then when you get the structure or the compound, how do we name the compound? Number 1, the same way as we have done with the alkanes, you make sure that you count the number of carbons, and then the parent name here, you don't look at the long chain. You look at the chain that contains the double bond. All right? So if the chain contains the double bond, you will know that this one is the alkene. And then the name will end with ENE. Let us go back to our table just to remind ourselves. We are going to have a break very soon. So I just want to remind you what we have on the table and what you should have written there. So the alkene, this is the group that we are talking about, where you've got the double bond between 2 carbons, and we don't have any for 1 carbon. For 2 carbons, we have ethene. 3 carbons, it will be propene, butene, pentene, hexene, heptene, and octene. They all end with ENE because they belong to the alkene homologous series. And then, so when you give the name, you will check the number of carbons that you have, and then the number of carbons will tell you which parent this compound will belong to, and then the suffix will end with ENE. And then, so we said when you look at the long chain must contain the double bond. So if it doesn't contain the double bond, then our name will be incorrect, because our concentration here is where is the double bond. And then step number 2, we'll look at step number 2 and step number 3 when we come back from break and see how this is done. And then from there we'll go to the example and see how do you solve the example. Welcome back from the break that you just have. I hope you were able to stretch your legs so that you can continue with our lesson today. Last time when we went for the break, we were talking about the alkanes. So let me just remind you what you have done before. We looked at the alkanes and how you give the name of the structures of the alkanes and take into consideration the rules that you must follow. And then we also did some drawing. How, when you are given the name, how do you draw the structural formula? Now we are going to look at the alkene. And we said the alkene from our table there, it contains the double bond. There must be a double bond between one of the two carbons. Then you cannot have an alkene for the carbon, for only one carbon, because the double bond has to be between two carbons. So let us continue with the rules and see how we name the compounds that belongs to this homologous series, the alkene. We said first you have to check the longest chain, and this longest chain needs to have a double bond. And then that will be the parent name. And then this parent name, remember you must also check how many carbons are there on the parent name. And then it will end with the suffix ene. If it has 2 carbons, it will be ethene. If it is 3 carbons, it will be propene, 4 carbons, and so on. So before we go any further, remember the table that we were doing before we got to the break. Let us go back to it and try and complete it using only this column. And then the last column you'll be able to do it yourself. So let us look at the structure where we've got 3 carbons. We said with 3 carbons, let's see how the structure would look like. Okay, the structure will look like this. You'll have carbon number 1 there, carbon number 2 with a double bond, and carbon number 3. So you'll see when we look at the second step for naming the compound, they say here you must number your carbon atom in the parent name. You begin at the end nearer to the double bond, and then you give the number of the position of your double bond, where you put the double bond. Okay, so let's see this one. If I number it from this, I'll have 1, 2, 3. So the name of this one will be prop. At carbon, after carbon number 1, I've got a double bond, which is ene. All right. If I change and put it this side, I'll have 1 double bond, 2, 3. So if I number it, I must number it from the side nearer to the double bond. So I'll have 1, 2, 3. So it doesn't matter whether the double bond is this side or it's that side, the name will still be the same, propene. And then let's check if we've got 4 carbons. 4 carbons, we have 1, 2, 3. Let's put the double bond there and carbon number 4. I won't put the hydrogens, but you must remember not to leave out the hydrogens. And then you must also remember that when you put the hydrogens, you must count the number of bonds that we have around 1 carbon. Like this one already you've got 2, so this one only needs 2 bonds. So we have only 2 hydrogens there because those 2 are there. And then this one has 1, 2, 3, and then only need 1 hydrogen for this second carbon. And then the last carbon will have 3 hydrogens around it. So be careful about the number of bonds that you have around 1 carbon, because sometimes you are doing the mistake of putting more than enough bonds around 1 carbon. So just be careful about that one. So this one, we are going to number it from the side nearer to the double bond, and that is this side, because that side is far from the double bond. 1, 2, 3, 4. Let me draw another structure where I've got, I'm going to put the double bond there, where I will have 1, 2, 3, 4. Or I can count from this side, 1, 2, 3, 4. So after carbon number 2 or after carbon number 2, I have a double bond. So the names here are not going to be the same. Even though this, we've got 4 carbons, we know that it should be viewed for 4 carbons. This one is also viewed. But then if I look at the first structure that I have there, after carbon number 1, I've got a double bond, E-N-E. But this one, after carbon number 2, I've got a double bond, E-N-E. So these are my isomers for the alkene. So for the alkene, if you need to do an isomer, what you do is you move the position of your double bond. If I move it from there to there, these are 2 different structures. But if I look at the number of carbons and hydrogens, they will be the same. So the molecular formula is the same, but the structural formula is different. So these are my isomers for the alkene. So just be careful when you complete the table that you can have here propene, but here you can have build 1 in, or we can have build 2 in. And then we have shown you with the structure the difference between build 1 in and build 2 in. All right. So you must also check the pent, that how many isomers can you form using the pentene. 5 carbons, 6 carbons, 7 carbons, and 8 carbons. So you have all the numbers there, so that you know when you look at the position of your double bond, it will tell you which one compound, or the name of the compound, is the correct one. So this is how you name the alkane, following the rules that we had. You said you begin numbering from the end nearer to the double bond. So you check where the double bond is, and then the double bond must have a lower number. And then this number you must indicate. You must indicate the position of a double bond by this way, that after carbon number 2, I've got a double bond. After carbon number 1, I've got a double bond. So there's my carbon number 1. After it, I've got a double bond. So there it is, the position of my double bond. And then this one, after carbon number 2, I've got a double bond. Or if I go from this way, after carbon number 2, I've got a double bond, and then that will be the name of this compound, butyl-2-ene. All right. The next point there says, if the double bond is at the same distance from either side, you can number from any side. Just as you have seen with butyl-2-ene, I can number it from left to right or from right to left. I still get the same position of my double bond. And then to the last point there at step number 2 says you must place the number between when you write the name. You don't write the number of the position at the beginning of the compound. You see, if you look at the books and then you follow what is in the book, sometimes you'll be wrong, because that is not the correct way of writing it. Because some books will write this one as 2-butene. All right? So we don't name it this way anymore. We don't name that one as 1-butene. All right? It's a wrong way, because in some textbooks they are still sticking on the old way of naming these organic compounds. All right? So they say here, you must place the number of the first carbon atom of the double bond between the parent name and the suffix. So between the parent name and the suffix, not before the parent name. So you must put it between the parent name and the suffix, just like we have done. So if you look at this one, this is what they mean. There is the parent name, there is the suffix, and between them you've got the number. All right? Okay, my color. So I've got a parent name there, I've got a suffix, and then between them there is my number of the double bond. The position of the double bond is between them. All right? And then step number 3 says must identify the number of substituent The name of the substituent is determined by the number of carbons. If there's one carbon, my substituent will be methyl, the same way as we have done with the alkane. If I've got two carbons, I'll have ethyl. And then you assign the number to each substituent, like we have done with the alkanes. And then if you've got two substituents that are on the same number, you must not use just one number. I will show you what we mean now. And then you arrange the substituent alphabetically. If you've got more than one, like if you've got two substituents of the same type, methyl, you use di. If there are three, you will use tri. And then you must also remember to use the hyphen to separate the number, and the prefix and the comma to separate numbers. So let's have a look at the examples. Okay, my papers, put them aside. Like I'm going to draw a structure here and then show you how we are going to name it. Let's say, for example, you've got this compound here with a 1, 2, 3, 4, and then there we've got one substituent, and there we've got one substituent. All right. So we'll have around this one you need 2 hydrogens, and then around this carbon you've got 1, 2, 3, 4. So this one doesn't need any bond there. Then that one will have 1, 2, 3. And then this one, 1, 2, 3, 4, 1, 2, 3, and that's the fourth one, 1, 2, 3, and 4. So this is the structure that I want us to give the name to. So according to the rules, they say when you've got a structure like this one, you number the carbons in the long chain. So let's check our possibilities. 1, 2, 3, 4. 1, 2, 3, 4, but I cannot choose that one. I cannot choose this one because this one doesn't have a double bond. I only choose the one that has a double bond. So I can go 1, 2, 3, 4, or I can go straight because all of them, if I take into consideration the position of my double bond, I get the maximum of 4 carbons. So this one is my long chain. So I said you number from the side where you've got the double bond. So there's only one side to number from here. You cannot number from both sides. So I only number it 1, 2, 3, 4. Okay? Because if I check here, my double bond is after carbon number 1. But if I number it from my left to right, this will be 1, 2, 3. And then after carbon number 3, I'll have a double bond. And then 3 is bigger than 1. Therefore, the only way that I can number this compound is the one that I just showed you. So we said it has how many? 1, 2, 3, 4. So if it has 4, I know that it's built, and all single bond, no, it's not single bond, I've got a double bond there. Therefore, it will end with E and E. All right? And then I must also check the position of my substituent. If I check here at carbon number 2, I've got that substituent with 1 carbon, and that 1 carbon is methyl. And then at carbon number 3, I've got another substituent with 1 carbon, that is also methyl. So according to the rules, they say if on the compound you've got identical substituent, if there are 2 of them, you will use di for 2. And then if there were 3 of them, you will use tri for 3. All right? So let us give the name to this one. At carbon number 2, and at carbon number 3, I've got the methyl. Remember, the rule says if I've got 2 numbers, I must separate these numbers by a comma. All right, 2, 3. Now I'm going to write a prefix, methyl, but there are 2 of them. Therefore, I put di for 2, and then methyl. And then my long chain has 4 carbons, this will be bute, and then the double bond appears after carbon number 1, and then it ends with ENE. So the name here is 2,2-dimethyl bute-1-ene. That's the name of the compound that we just drew there. All right. Let us do another one. The same with the same number of carbons, and then we increase the substituents. 1, 2, 3, 4, and then we say here we've got a substituent, there we've got a substituent, and there we've got another substituent, and then we put our hydrogens. 3 hydrogens around this one, 3 hydrogens around this one, and then this one is okay, and 2 hydrogens around this one. Okay, so if we have to number this one, this compound, we also have to start to the side nearer to the double bond. So this is carbon number 1, number 2, number 3, number 4. I can go that way or that way. I'll still get 4 carbons. So it gives me the maximum of 4 carbons. But this one, if you have a look at it, we say there you've got a methyl, and then we have another methyl there, and there's another methyl at the bottom here. All right. So let us give the name to this compound. So when you give the name to this compound, we say you check the position of your substituent. At carbon number 3, it's not number 3. At carbon number 2, we've got that substituent is methyl, it's still methyl, it's still methyl. So all of them, all the 3 are identical. So, and then at carbon number 3, I've got that methyl. Again, at carbon number 3, I've got this one. So at carbon number 2, I've got that one. Carbon number 3, I've got methyl. And another, again, carbon number 3, I've got this methyl. So I've got 2.3.3. So I've got 3 substituents. I must also check here, I've got 3 numbers, 2,3,3. Now I'm going to write the prefix. I must put a hyphen, dash. There are 3 of them. I'm going to use tri, methyl, and then the long chain has 4 carbons. That's bute. After carbon number 1, I've got a double bond, ENE. All right. So here we've got 2,3,3 dash trimethyl bute dash 1 dash ene. So I've showed you when we've got 2 identical substituent or 3 identical substituent, how do you number and name the compound? All right. So let's check what we have in our presentation. There we've got the compound with 1, 2, 3, 4, 5, 6. They have numbered them for us. If I check from this side, 1, 2, 3, 4. So after carbon number 2, I've got a double bond, and then if I count from left to right, after carbon number 1, 2, 3, 4. After carbon number 4, I'll have a double bond, and 4 is bigger than 3. Therefore, I cannot use the other numbering except the one that is shown here. So if I check here, this has a double bond. It belongs to the homologous series of the alkene. Therefore, my suffix for the name will end with ENE, and then it has 6 carbons. For 6 carbons, my parent name will have HEX. I've got a double bond, and then when I check after carbon number 2, that's my lower number, that's where I've got a double bond. And then if I do another numbering, it will be at after carbon number 4. Therefore, that one will be incorrect. So I'm going to take the double bond after carbon number 2. So it will end with, so the parent name will be hex-2-ene. But that is not all, because if I check here, I've got a substituent at carbon number 3. I've got another substituent of at carbon number 3, and those No, this is carbon number 4. Now the numbers are confusing me. Don't let them confuse you also. Carbon number 3, I've got this substituent. Carbon number 4, I've got the same type of substituent. So here I've got identical substituent of 1 carbon and 1 carbon. Still at carbon number 4, I've got this substituent with 2 carbons. Alright? So in that case, I know that E comes before M. But then the E that comes before M is not going to determine the number of my carbons, the numbering of my carbons. I'm not going to change my numbering because of the E that comes before M. The numbering for the alkene is determined by the double bond, not the substituent. The substituent will be there, but they will not determine the number, how I'm going to number my parent name. So if I check here at carbon number 4, I've got E, and then carbon number 3, I've got M, carbon number 4, I've got M. And then, so I know that E comes before M. So ethyl will come before methyl. So the name there will be at carbon number 4, I've got methyl. At carbon number 3 and carbon number 4, I've got 2 methyl. Therefore, I put di to 3,4 dash dimethyl hex 2-ene. So that's the name of my compound. So let's have a look at another example, because this one I think will need another example so that you are not worried about naming the compound. So I'm going to draw a compound here, and I need you to, for a few seconds, just to think about the name. Made some mess there, so you cannot see what is happening. We've got 1, 2, 3, 4, 5. 1, 2, 3. There's double bond there. 4, 5. 1, 2, 3, 4, 5. And then we had a substituent there. 1, 2, 3. We had another substituent there with the double bond and 2 carbons. I'm going to put another substituent there with 1 carbon. 1, 2, 3, 4. 1, 2, 3, 4. Therefore, I cannot put another substituent there. Let me put another one there. Okay? 1, 2, 3, 4. And the hydrogens around each substituent and the parent name. So let us give the name to this compound that we have here. I'm going to give you a few seconds after I remove my hand here so that you can see the structure. You've got 1, 2, 3, 4, 5, and then there you've got 1, 2, here you've got 1, 2, and then there you've got another substituent there. Quickly draw this so that we can give the name to this compound. All right. After drawing this structure, now we must check. Let us label our carbons in the long chain. We've got 1, 2, 3, 4, 5. This is the long chain that you can take. You cannot take this one. 1, 2, 3, 4, 5. You still have 5. But then you won't know how to call that one because it's going to give you problems. So we'll take it in the long chain where we've got 5 carbons. So I can label them from 1, 2, 3, 4, 5. Or I can label from this side where I've got 1, 2, 3, 4, 5. Okay? So if I check here, remember we said when you label the compound containing double bond, you don't worry about the substituent. Your worry is with where the double bond is. So if I check here, after carbon number 3, I've got a double bond. And then after carbon number 2, I've got a double bond. Therefore, I'm not going to take that numbering. the bottom numbering is not the one that I will consider, because it gives me the bigger number. But this one, after carbon number 2, I've got a substituent, therefore that's the one that I'm going to consider. Alright? So if I have to give the name to this one, I will say, if I check there, I've got a methyl, I've got another methyl, there, I've got another methyl, but here I've got an ethyl. Alright? So let's go to the name. There are 1, 2, 3, 4, 5. So I know the parent name will start with pent. Will start with pent, and it will end with E. And the number, I must not forget that between these two, I must put the number of the double, where the double bond is. So the name, we say, if I check, I've got E and M, but I know that E comes before M. And then at carbon number 3, I've got an ethyl. All right. And then at carbon number, another dash. At carbon number 2, again at carbon number 4, another one at carbon number 4, I've got 1, 2, 3. My numbers are also 1, 2, 3. And then I put a dash. Because there are 3 of them, I must start with try to indicate that there are 3 substituents of methyl. And then the parent name has 5. We said it's pent. And then after carbon number 2, I've got a double bond, pent in. All right. So the name there is 3-methyl-2,4,4-trimethyl pent-2-in. So that's the name of this structure that we have there. So before I go on, let me just check your part of your homework. If you check there under drawing the structures, we've got this one. We've got this one, and that has an in. Therefore, you have to draw the structure for this one. And then how do you do it? You start with the parent name. Build, you know how many carbons are there. And then they say after carbon number 1, you've got an in. And then after that, label your carbons and put the substituent where it's supposed to be. So number 5 also is an in. You also do the same. Check the parent name has how many carbons. After which carbon you put the double bond. After that, label all other carbons, and so that you can see where your substituents are supposed to be. All right. So that's the next activity that you'll be doing as part of your homework. Back to our presentation. So we are done with the alkane, we are done with the alkene. We are doing the last hydrocarbon, which is the alkyne. So the alkyne has a general formula of CnH2n-2. So if we go back to our table, you remember with the alkyne, you don't have the one with one carbon, because we said the triple bond has to be between 2 carbons. So we don't have the name there. We'll have ethine, we'll have propyne, and so on. The same way as we have done with the alkene. You must also check here where your triple bond is, because we need to indicate where the position of the triple bond, where the triple bond is. So it's important to indicate the position. So try and draw the same way as we have done with the alkene. Draw the structure for different alkynes and see whether the possibility of the different names of the alkynes that you might have, and put them down there as your possibilities in your table up to number 8. All right? And then we say the functional group, we've got C, triple bond C. This is unsaturated, so it's most unsaturated, unlike the alkene and the alkyne. I mean the alkane and the alkene. Remember, alkane, we said they're saturated. We've got single bonds between carbons. Therefore, it's not possible to break that single bond. That's why we refer to them as saturated. Alkene are unsaturated. You break the double bond to single bond. Alkyne is most unsaturated. The triple bond, you'll break it to double bond before you can break it to a single bond. So these ones, they are most unsaturated as compared to the alkene. Okay, we said you've got triple bond between carbons, and then you only have carbon and hydrogen. So we refer to them as the hydrocarbons. All right? And then how do you name the alkyne? Just like the alkene, you choose the parent name, and this parent name must contain a triple bond in the long chain. So you check that in your long chain you've got triple bond, and then the parent name will end with YNE. All right? And then the second step, you number the carbons in the parent name. You number it the same way as we have done with the alkene, where you check that your triple bond has the lower number, just like we have done with the alkene, where we check that the double bond has a lower number. And then from there, if your triple bond is in equal distance from both sides, it doesn't matter which side you start from, because it will contain the same number. And then you place the same way as we have done with the alkene. When you write the name, between the prefix and the suffix, we put the number. So between the parent name and the suffix, we must put the number. Where do we find the triple bond? All right? And then you must also identify substituents, if there are substituents, the same way as we've done. If the substituent contain one carbon, it will end with methyl, and then if it has 2 carbons, your substituent will be ethyl. So you assign the number to this substituent. But remember, the substituent doesn't determine where you start numbering. The triple bond or the double bond determines where you start numbering. And then if you've got more than 2 substituents, that is the one that contains ethyl and methyl, you consider the alphabetical order, that E comes before M. And then if you've got the identical substituent of either methyl or ethyl, you put a di if there are 2 of them, or tri if there are 3 of them, just like we have done with the previous example. And then the hyphen and the comma, the hyphen between the prefix and the number, and the comma between numbers, that is very important, because you forget it if you are in a hurry and you're excited because you know the name of this one. Let us look at this example that we have. If we look at it, there are 7 carbons on the long chain, and then that's carbon number 1, number 2, number 3, 4, 5, 6, 7. Or we can number it from 1, 2, 3, 4, 5, 6, 7. But if we number it from that side, if you go that way numbering, you see that the triple bond will come after this carbon, which is number 1, 2, 3, 4, 5, carbon number 5. And we know that 5 is higher than 2. Therefore, the blue that you are seeing there is the correct way of numbering your carbons. So we number it from there. And then we identify here you've got a substituent at carbon number 4. Therefore, when we give the name to this one, you look at the substituent. There is another substituent at carbon number 5. And the 2 substituents are identical. They both contain the same number of carbons. That's why we say they're identical. Therefore, if there are 2 before you write the name of the substituent, you will put di representing 2. And then if there were 3, you will put tri representing 3. So if you have to give the name to this one, we say at carbon number 4, comma, carbon number 5. So we'll have 4, 5, and then 2 substituent that identical, dash, dimethyl. The parent name has 7 carbons, which will be hept. And then dash, after carbon number 2, you've got ine. Therefore, let's have a look at how the name should be written. We said it's an alkyne because it contains triple bond. So it will end with YNE. And then it has 6 carbons, meaning that it's not 6, it's 7 carbons. Sorry for this. Please correct that. That is 7 carbons, not 6. Therefore, it will be hept. And then the lower number for the triple bond is at carbon number after carbon number 2, because you see red says after carbon number 5. So we'll also need the blue for that. So the parent name will be pent-2-ine. But we know that we've got 2 methyl substituent. Therefore, the correct name there is carbon number 4, comma, carbon number 5, dimethyl hept-2-ine. So that's the correct name for this one. Let us look at another example so that we try and get this name and the substituent and the position of the triple bond correct. Let's draw another one here. 1, 2, 3, 4, 5, where here we'll have triple bond. So let's check and verify that each carbon has enough bonds. 1, 2, 3, 4, 1, 2, 3, 4. So it's correct. And then let's put here the hydrogens. And then this one, it doesn't need any substituent because already it has, or doesn't need any hydrogen because it has, the number of carbons are right. And then let's put a substituent there with 2 carbons and another one there with 1 carbon. Let me put the other carbon there. So this one will have 3 hydrogens. I just want to confuse you. This one we have 1, 2, 3, 4. Okay, that one has, we'll put 3 hydrogens around it. This one, 1, 2, 3, 4. Okay. This one you said it's okay, that one is fine. So if you have a look at this structure that we have, the long chain has how many carbons? If you look at the long chain, you will look at that as the long chain. But this long chain bends. So you just have to be careful that the long chain can also bend. So this is not a substituent, it's part of the long chain. Alright? So we've got 1, 2, 3, 4, 5, 6 carbons in the long chain. And then if I go this way, I've got 1, 2, 3, 4, 5, 6. I still have 6 carbons in the long chain. But, okay, now it will still make sense. Alright? But I'm going to take that one as my long chain. I'm going to number it 1, 2, 3, 4, 5, 6. And I'm going to use another color for numbering. 1, 2, 3, 4, 5, 6. So when I check my numbering and where my double bond is, if I check the first numbering, the black numbering, after carbon number 2, I've got triple bond. And then the other numbering, after carbon number 4, I've got triple bond. Alright? Therefore, the correct numbering that I'm going to choose is the one that gives me the lower number, which is the bottom one, from right to left. So, because I know that this is an alkyne, I've got 6 carbons, so it will end with hex for 6, and then I'll have YNE as my suffix. Therefore, between these two, I'll have the number that indicates the position of my triple bond. And then I check. I've got substituents. I've got that substituent at carbon number 3 and number 4 because he said we take the bottom. Let me just cancel that one because I'm not taking that one so that I don't get confused. And then at carbon number 4, I also have that substituent. So if I have to write the name for this one, I'm going to say at carbon number 4, I've got a substituent E and M. Therefore, if I remember well, ethyl, methyl. If I remember my alphabetical order, I know that E comes before M. Therefore, this will be 4-ethyl. And then I've got another substituent. And therefore, I must put a dash because I need to indicate the position of that substituent as 4. And then 1 carbon, methyl. And then I've got 6 carbons, hex, dash, after carbon number 2, I've got triple bond. All right. So the name for this compound is 4-methyl 4-ethyl 4-methyl hex 2-I. That's the name of this compound. So if you go to the homework that you are going to have, there is the structure that you must draw. So this time I didn't give you the structure that you must name. I want you to draw the structure, the structural formula. I gave you the name, therefore you must give me the structural formula. So let's check whether I've got another one there that contains a triple bond. It's not there. They are all single bonds. Therefore, it is this one that you must draw. If I go a little bit up there, this one, you just have to be careful when you do this one. Just draw, before you give the name for this compound, my colors have disappeared. If you give the name for this compound, just try and draw the structure before you give the name so that you can see what type of structure is that. And then you'll be able to give the proper structure. So just be careful also here where you've got CH2 in brackets and then there's 3 there. And then this 3 means you've got those CH2, you've got 3 of them. So it's CH2, CH2, CH2. That is what this means. And then this one says you've got CH3 and there are 2 of them. So just be careful that draw the structure before you write the name so that you can see the complete picture of this condensed formula. And then you'll be able to give the correct name. That one, it won't give you a problem. So number 2 and number 3 and number 4, before you give the name, draw for yourself a structure so that you can see the whole picture for this condensed structure. All right. So let's go back to the presentation. Later we are going to look at the haloalkane and the alcohol and the other homologous series. So I won't go into the haloalkane because I don't want to give you more than enough information. But what we can do is we can check if we've got a different name. How do we draw the structure of that indicating the triple bond? Let me switch over to this so that you can all see. Let's say here they give you pent 2-ine. All right, pent 2-ine. What does this mean? It means after carbon number 2, I've got the triple bond. So if they say you must draw this, you remember that pent has how many bonds? I mean, how many carbons? It has 1, 2, 3, 4, 5. Therefore, after carbon number 2, I can count from there and say 1, 2. After carbon number 2, I've got a triple bond. and then there will be a single bond there. So this will be the structure for pent-2-ine. But then it's not a complete structure because it must also contain the hydrogens. Remember, I said to you, if you do not indicate the hydrogens, you will be penalized for that. So the second carbon, I've got 1, 2, 3, 4 bonds. So I don't need a hydrogen for this one because already it has 4 bonds. And this one, I've got 1, 2, 3, 4 bonds. And for this carbon, I don't need to have hydrogen because there are enough bonds. And then this one will have 2 hydrogens. That one will have 1, 2, 3 hydrogens. So this is the correct structure for pent-2-ine. All right. Let's say, for example, let us put some substituent into this and see how the structure will look like. Let's say at carbon number 2 and carbon number 3, you've got a dimethyl, and then a hex 2-ine. All right. They say you must draw the structure of this name. So if we check, here we've got where you must start when you are given the name and you need to draw. Start from here. You've got 6 carbons. So you draw those 6 carbons. 1, 2, 3, 4, 5, 6. All right? And then you check. After carbon number 2, I've got a triple bond. Carbon number 1, number 2, I need to draw or to put triple bonds there. And then the rest of other bonds will be single bonds. Single, 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 single. And then the other bonds there. 1, 2, 3, 4. Therefore, we need to swap that around so that it doesn't make confusion. Because if you look at that one, it's after carbon number 2, and already 2 has 4 bonds. Let's say carbon number 5 and carbon number 4 and number 5. 4, 5 dimethyl. So we'll number them 1, 2, 3, 4, 5, 6. All right. So at carbon number 4, you've got that substituent, and carbon number 5, you'll have that substituent. So when you are given the name, start with the parent name. Start with the parent name and check how many carbons you have. You have got 6 carbons, and then after carbon number 2, I've got a double bond. So it works easier and correctly for you. And then from there, you will indicate where your substituents are, carbon number 4 and carbon number 5. So this is what you must do with the activity that you are going to work with for your homework. All right. So what is left for you now is you will get the worksheet from your class teacher, where you will go and do those activities, 2 activities there. And then when you are done with them, when we meet next week, before we get into the haloalkane and other homologous series, we'll first work on the activity so that you check yourself whether you've got it correct. And then from there, we'll continue with our lesson. Thank you for tuning in. Now I'm signing off and say bye-bye. Till next time.